Chemistry, metals, nonmetals, and metalloids. All right, so this version of the periodic table you can see is kind of broken into these three sections here. Okay, we have metals, metalloids, and we have nonmetals. Okay, so the blue ones are all of our metals. Our yellow ones, hydrogen included, are our nonmetals. And then we can see the metalloids, which you've learned about earlier, on the staircase here. You can also see that we have representation of gas on here, is with a balloon, I guess. Liquid has a drop, okay. Solid is a little box, okay, and synthetic elements, being the ones that are made by man, are there. Okay. So each of these classes has characteristics, chemical and physical properties. By knowing whether an element is a metal, nonmetal, or metalloid, you can make predictions about its behavior. So physical properties involve luster. Okay, that's how shiny something is basically. Okay, silver gray in color except for gold and copper. Okay, that's the exception here. Another physical property is that metals conduct heat. Okay, you can see this iron rod. Okay, they also conduct electricity. You can see these are copper wires lighting up a little light bulb from some batteries. Um, Metals are malleable, okay, or have malleability. This is the ability to bend without breaking. Um, Ductility is the ability to be drawn into a wire. Okay. All are solid at room temperature except for one, mercury. Okay. There's something called gallium, and gallium is solid at room temperature, but if you put it in your hand, it'll melt down and look like mercury. Mercury happens to be toxic. Gallium is not. Um, Another physical property of metals is that they have a high melting point, so it requires very high temperatures to melt them. Now into chemical properties. With the exception of tin, lead, and bismuth, metals have 1, 2, or 3 valence electrons. Remember, those are the electrons around the outer shell. Most of the metals are not main group metals, okay? Groups 3 through 12 in period 4, and going to the bottom of the periodic table are the transition metals. Okay, and you will have learned this earlier. All transition elements are metals. Okay. The chemistry of the transition elements is more complex than the main group elements due to the more complicated atomic structure. Two series of elements, okay, atomic numbers 58 through 71 and 90 through 103, are placed below the main body of the periodic table because putting them in the proper position would make the periodic table too wide. These are the lanthanides and the actinides. If you look at the periodic table that I gave you, you'll notice that little chunk below, and you'll also notice that they go actually into a place just at the bottom left of the periodic table. The lanthanides are given that name because they follow element 57, lanthanium. Uh, Lanthanides are also called rare earth metals because their rare earth elements, because their natural abundance on Earth is less than 0.01%. Okay, all of the lanthanides have similar properties. And so here is some of them here. All of the actinides are radioactive. None beyond uranium occur in nature. Their chemistry is unpredictable because of their atomic structure. Nonmetals are abundant in nature. Okay. Oxygen and nitrogen make up 99% of the Earth's atmosphere. We've talked about this already in class a little bit. That pie chart right there kind of um, shows the breakdown. Okay. Carbon is found in more compounds than all other elements combined. Okay. With the exception of carbon, the nonmetals tend to have 5, 6, 7, or full valence electrons. You'll see that carbon would be right here. Okay, carbon would be right here. Most do not conduct electricity except for carbon. Okay, most are poor heat conductors, and most non-metallic solids are brittle. Okay, that means that they break easily. And then I want you to watch this little video here. Okay, this is a video that I made when I went with some kids to the Museum of Man and Nature with some grade 9s a little while ago. Many are gaseous at room temperature. Okay, so that was a balloon filled with hydrogen. Okay, that they lit on fire. Um, they lack the luster typical of metals. Okay, this is beryllium. So they're not shiny like metals are. That metallic shininess. Their melting points tend to be lower than that of metals. Now on to the metalloids. Okay. The metalloids have some physical and chemical properties of metals and others of nonmetals. They act mostly like nonmetals but conduct electricity very well. Okay. And are also called semiconductors and very important in our electronics. And they can easily control the flow of electricity. Okay, so that's how much the direction stop and go. Super important for like your cell phone and TVs and stuff like that. Okay. Differences in metals, nonmetals, and metalloids. Differences in their properties occur because of the different ways the electrons are arranged in the atoms. The number and arrangement of valence electrons, and how tightly the atoms hold those electrons are important factors in determining the behavior of the element. So metals in general, the valence electrons of metals are loosely bound to the positive nucleus. They are free to move in solid metal and are easily lost. Metals tend to lose their electrons in chemical reactions. This freedom of motion accounts for their ability of metals to conduct electricity. So nonmetals and metalloids. The valence electrons in atoms of nonmetals and metalloids are tightly held and are not easily lost. Okay. When undergoing chemical reactions, nonmetals tend to share electrons or to gain electrons from other atoms, usually metals. Okay, so where do you see this on the periodic table? Right? We see it in the staircase, okay, where the metalloids are.